I have just got us going on YouTube. It's great to see everybody joining again. Nice to have you all back.
Yes. Hello, everybody. Oh, where's everybody coming in from? Let's see.
BC, Toronto, Markdale, Regina, Ottawa, Victoria.
Smoky Regina. Well, it's smoky Toronto too. So
smoky here too, yeah. Smoky everywhere right now. Great to see you all. Careful up in Timmins. It's I don't know how bad it is around Timmins. I know around Thunder Bay it's been pretty toasty. Alrighty. Well, excellent to see you all. We will get started. It's nice to be back. We took a little bit of a break over June, and we are still continuing to take a little bit of a break over July and August with Insider's Guide to give ourselves a little breathing room and to let Chris get up to his observatory and to all that good stuff, recover from the General Assembly, everything like that. So Chris have you had some good observing this summer so far?
No. I think it was one clear night during the new moon period, the last new moon period. And no, not worth traveling out of town for it. We still have the Perseids.
I really hope the Perseids, there's no rain this year because, oh man, it's supposed to be a good one. And yeah, it's been just not particularly good for astronomy this summer. But the good news is that we're going to assume it's all going to turn and it's going to get way better for the rest of the summer. And we have some excellent stuff for you today for what to look for over the remaining months that we have.
Exactly. Yeah. So it's going to be a kind of a light, frothy summary edition of Insider's Guide, not a heavy information dump, but more of just to review what's up in the sky and some suggestions for people to get out and look at. I've been doing a few of these lately, and I've been finding that's really effective is to break it down and give people suggestions for naked eye observing. So if you're with family or friends or hanging out and you don't have binoculars or a telescope or anything, there's still things you can do with sky observing. And then if you've got binoculars, some things to look at. And then if you've got telescopes, some things to zoom in on and wow your friends. And then, I think we've got time left at the end. If people want additional observing suggestions, we can add into that as well. So the big news though right now is the smoke, the forest fire smoke. So if you've been out to look at the sun or the moon, you've noticed that the sun is sort of dimmer and more orange, and the moon is looking brown or orange at nighttime. And that's going to affect your observing. It's going to overall reduce the transparency of the sky and diminish the number of stars you see at any given time. I remember I did about 3 years ago, maybe, RAS Toronto Center did a large observing star party for a mosque that's in Richmond Hill, in Vaughan actually. And we had hundreds and hundreds of people, and we had, I think, 6 or 7 telescopes lined up. And the sky was completely brown and murky from smoke. And you could tell the moon was this golden color. And then we could barely see, Jupiter, we could see Saturn. Mars, you could sort of barely make out in the murk. You couldn't see the summer triangle, maybe just Vega, but not the other two. So thankfully we had go-to telescopes and we were able to, show objects that we're tracking. But it's amazing how bad the smoke is. So if people are interested, I'm just going to share my screen here and bring up some examples of that. So let me just
one of the things that I noticed this last night here in Toronto, is that it was 6 p.m. and the shadows were red, and not the shadows, the sun on the ground was red, like where the sun was coming through. I noticed this coming through like a window, and it was like red. The light inside was red. It was just so weird to see. It looked like the sunset at 6 p.m.
Yeah. So this is the one of the 2 websites that are my favorite for deciding whether or not to go observing or not. This is ASTROSPHERIC. And if you give them an email address, they'll actually up your usage to allow you to save observing sites. So I've got some of our GTA dark sky sites in here. I've got the DDO, I've got the CAO from the Toronto Centre up near Thornbury. And you can see all the little yellow stars where the observing sites are set. These are actually ones built into the software. These aren't CAO and DDO because these are in the US, but you can just with one click bring your sites up. And you get a panel here, hour by hour of each day, so 24-hour boxes in each day. The top one is the cloud cover, so dark blue is clearest and white is fully cloudy. And then the next one is the transparency, and that's how clean or how clear the air is. And you can see that the transparency is impaired for much of this due to the smoke. And then the bottom one is the seeing conditions or the stability. And so if there's a lot of wind or something or turbulence at high elevation, it'll diminish the seeing. So don't just use the weather network and say, oh, it's going to be clear, and then make a big trek to your observing site, because without checking some of these other options. You know, we have Toronto Centre members that are going, yay, it's going to be clear. Let's drive an hour east of Toronto to the dark sky site. And somebody else said, well, I wouldn't go because it's going to be so smoky that you're not going to see much. So, or if you're imaging as well. So this is a good website, and it actually gives you a number of days. It can advance into the future. It also gives you the ISS passes, the space station passes, the temperature, humidity and the temperature, moon and sunrise and set times, and then it'll go into the future as well. So you can look for a bit of less detail into the future. So this one's pretty good. The other one I like is Clear Outside. Let's see if I can find Clear Outside.
I'm sitting around listening, being like, yeah, this is great, except I should be sending links in the chat. So here's the Astrospheric link there.
So I'm going to put L3T1, 2, 3. I'll just put something near me. So this website does a similar sort of idea. It's organized a bit differently, and you've got a little more granularity, but it's again hour by hour. But I find that this one is a little more pessimistic, so it's a bit safer. I mean, if you take the worst case scenario, then you won't be disappointed, generally speaking. So this one's telling me that tonight, after, by tomorrow morning, it'll be sunny tomorrow morning. It'll be fully cloudy, after midnight tonight. And you can run down and expand every day. You can see the green is good, red is bad. So it says Wednesday night for Toronto, it's going to be relatively clear in late evening and then get a bit of cloud and that kind of thing. So those are a couple of websites I like to recommend. But if you go back to Astrospheric and you hit the smoke button here, it'll give you, purple means bad, means smoke.
Ooh.
And this actually lets you do, over time, a snapshot of what the smoke does, predicted to do over time. You can see that this is 1 in the morning. So you can you can look ahead and see, when is the smoke going to be less or more of a bother, predictability wise. And there are different layers that are available in this option as well, transparency, smoke, and so on. So that's a tool that you can play with if you want to plan whether or not to go observing and how far to travel from home. Let's see, what else should we talk about? So I thought I'd do a quick planet roundup. So I'm using Stellarium as always. Let's bring it into this evening. And you may have had your eye on Mars and Venus. Let's get the planets up here. I think I've got them Alt P. There's my planets. There we go. So Venus and Mars did their close pass, their close conjunction on the July 11th, 12th. And now Venus is continuing to swing away from the sun while Mars is being carried towards the sun by the motion of the sky, the 4 minutes westerly motion of the sky every day due to Earth's trip around the sun. And so they're actually moving farther and farther apart every night. Right now, they're a few finger widths apart. So Venus is about 190 times brighter than Mars. And you can see Mars is so low that you're seeing it through almost 11 times the thickness of the atmosphere, of Earth's atmosphere, compared to something that would be at the zenith. So it's going to be reduced in brightness by all that extra atmosphere. So Stellarium offers you the visual magnitude of the object, 1.84, but how much it's extincted or reduced by all that extra air you're seeing it through. So its effective magnitude is much less, 3.26. But if you find Venus, what you can do, Venus, by the way, won't be very high. It's only, by the time it appears after dusk, it might be a 10 degrees above the horizon, a fist's diameter or so above the horizon. So you may have to walk around to avoid the buildings and trees in your neighborhood in order to see it. Venus will be with us until about New Year's. It'll start to head back down towards the sun right around the time that the year is coming to an end. But if you want to try for Mars, it's about 190 times dimmer than Venus. It's a few finger widths to the lower right, and that's increasing a little bit every night. You know, give it a go. It makes a neat little trio with the Regulus. So Regulus is the bright star in Leo. I'll just put up the constellations here. On Wednesday night, so tomorrow night, Venus will be kind of hanging out there with Regulus, and then a couple of nights after that, they'll sort of form a line. So for the rest of this week, you can see if you can use the combination of Venus and Regulus to help you find Mars. Let's see, what else is Venus going to be up to? So we're going to lose Mars. It'll return to rising before midnight in about mid-August of 2022. So you'll be able to see Mars before dawn if you want to get up or stay up late. But to see it in the evening before midnight, you have to wait till a year from now. And then December 2022 is when we're going to have the next great Mars opposition. So this is not the Mars year, but next year is. But Venus is going to hang around in the western sky all year long for the rest of this year. And it's a cool project to look at Venus in a telescope, because you'll discover, as Galileo did, that Venus exhibits phases, and it also varies in its size, its apparent disk size, because of the fact that it spends part of its time farther than the sun from us and then moving into that zone between us and the sun, so it increases its distance. So it's actually in the process of coming from behind the sun, and for the rest of this year, it's going to reach greatest elongation around, let's see, I think that's November, Halloween. It'll reach its furthest extent east of the sun around Halloween, and then it'll start swinging back. And as it does that, it's moving into the space between the sun and the earth, and so it'll be starting to get bigger in size, but it'll also become a crescent. So if we, I'm just going to turn off the ground and the daylight here and just jump ahead month by month. And you can do this. You can do this by making kind of a Venus log and noting it with your telescope, month by month. So here's now, August, September, October, November, December. Look how much bigger it's getting. So I think it's right now it's about 1/150th of the moon's diameter now, and by the end of the year it'll be 1/42nd of the moon's diameter. So about 43 arc seconds, which is bigger than Jupiter in the telescope.
So I had a very hard time when I think it was you, Chris, who first taught me this, but when I first learned that, of course, Venus's illumination, percent illumination gets smaller, but its brightness gets brighter, because I'm used to the moon, whereas like the higher percent illumination, the brighter it is. It's sort of one of those natural connections where, like, if it's more lit up, you assume it's going to be brighter, but because Venus is getting bigger in our sky, the lower the percent illumination, the brighter it actually appears. Is that right, generally speaking?
Yeah, because it's a combination of how much of it is illuminated and how close it is to us, and the effective size of the disk. So in fact, there's a phenomenon astronomers use called the greatest illuminated extent. That's what you're talking about. And that would be the day of the year when Venus would be kind of put the most light through your eyepiece. The combination of its phase and its diameter would combine to give you that. I've actually got that here. I can simulate those for you. I made some bookmarks. Let me just put on my bookmarks. So let's see, we've got Venus. So we have Venus on October 9th. What's that one? Okay, that one is, I forget what's happening October 9th, but that might be the one around Halloween.
It's going to be near the crescent moon and Scorpius.
Oh yeah. So October 9th is a conjunction. Yeah, that's the one where the crescent moon will make a pretty photo op. Yeah, so that'll be a nice night to look for. And it's in the claw stars of Scorpius. Can you see them? There's
Cool.
the claw stars of Scorpius. And Antares sitting there. It'll be a fantastic photo op. October 9th. Yeah. Yeah, so then we've got October 29th is when it's farthest from the sun. So that'll be half illuminated because it's rounding the outside turn of its orbit. And then we've got, let's see, on November 3rd is when it's the so-called greatest illuminated extent. So it's a kind of it's not something for everyday people, everyday observers. It's kind of a thing that, you know, the professionals talk about. But it's basically, if you were to measure the output of the light through your eyepiece, graph it up, that this would be the date where you get the max.
I just find it's so neat when you're like observing it yourself and you're out there, and it's that sort of the answer to the ever-present 5-year-old inside of you going, why is it this bright, and why is it getting dimmer, and why it's the answer to why, even though we don't really need to know the exact like point where it is its brightest. It's just so cool to know that it's not just how lit up it is.
So yeah, and thinking about that same concept, so the night of the year when Venus will look the brightest to your eyes without a telescope is December 7th. And again, it'll max out in its visual magnitude that night. So
Cool.
By a little bit, it's not going to be like a huge difference from one night to the next. But so we've got a whole year of cool Venus looking to do. Not terribly high in the sky. So you can see even at 6 p.m. on December, it's still going to be 5 air masses that we're looking through for Venus. If we go back an hour, catch it while it's not quite as dark, it's still 3 air masses. So, you know, you get what you get. All right, so that's Venus. So yeah, Mars is gone, but we got lots of time to look at Venus. Let's go back to now and talk about Jupiter and Saturn. And we're gonna dive deeper into Jupiter and Saturn next month. We're gonna talk about all kinds of cool phenomenon to look at, and also some, you know, tips for filters and things like that we can do next month. All right, so I'm just gonna pause the time here. Okay, just pause. Boom. I like to pause stellarium. So tonight, Saturn's coming up around 9:30. Jupiter is coming up about an hour later, and they're going to stay about 20 degrees apart for the rest of the summer. They'll just chase each other across the sky. If you've got your telescope, Saturn, what's cool about Saturn is that compared to last year, between now and March of 2025, from our perspective, the rings of Saturn are closing a little every year. And in March of 2025, we're going to see the planet edge on and the rings may disappear for a week or so. I'm not sure. I haven't myself observed it, but maybe someone in the chat has seen it when it's like that. So that happens about every 15 years. Right?
That's so cool. Like sorry, is that Saturn's moving or our position relative to Saturn?
So it's because every planet in the solar system has an axis of rotation that's fixed in space, right? And it keeps that axis of rotation regardless of where it is in its orbit, right? So for us, that's why sometimes we're pointing towards the sun and sometimes we're pointing away from the sun, because we're always pointing towards Polaris, regardless of whether we're on Polaris side of the sun or with the sun between us and Polaris. So it varies, right? So Saturn has a tilt that's similar to Earth's, about 26 degrees or so. And that means that when we are at kind of the point in the orbit where it's at its winter solstice, then its axis is pointed towards the sun. And when we come between the sun and Saturn, we're seeing that tilted at a max towards us, right? And then 15 years later, Saturn's at its summer solstice where it's tilted the other way. And so the rings will be tilted up the other way. And midway between those 2 points is when we're seeing Saturn edge on. So at its equinoxes.
Ah, cool.
Yeah. Yeah. So the seasons on Saturn are 7 years long, right? 7.5 years
Right.
long compared to Earth. So yeah.
Cool. Huh.
Yeah. So that'll happen. So, but my point is that between last year and this year, the rings have closed up a little bit in the ensuing 12 months. And so now we're able to see a little bit of the ball of Saturn below the rings, whereas we couldn't last year. So what I can do is I'll fix this in place and I'll go back to last year. Let's see if this will work. Yeah. So that's last year.
Cool.
So that's last year, this year, next year, and so on.
Cool.
Yeah. So that could be another project you can do, is kind of sketch it every year and see the difference as it comes around.
Super cool. A question from Brian. Can you see Saturn's moons with your telescope or with a telescope?
Yeah, so you can almost be guaranteed to be able to see Titan. So Titan is magnitude 8.47. That's even binoculars brightness. If you know where to look, and if you've got, but you need a clear sky. So what you can see with a reasonably big telescope, maybe a 8 or 10 or 12-inch aperture telescope, and a nice dark night with good transparency and good seeing, you could see 5 or 6 moons. And it's kind of fun to be able to get your app out and figure out where the moon should be and then track them down in the eyepiece. So you can see, usually Rhea, Dione, Mimas, Enceladus, Tethys, and so on, the sort of the biggest of the set. And you can do that game where you observe night after night and see the moon's arrangements vary from one night to the next. But because of that tilt, because of that, that solstice equinox tilt that Saturn has, that allows its moons to appear both alongside the planet, but also above and below. Right, because its whole system is tilted, which allows things to ride high and ride low, as opposed to Jupiter, which is all in one line for us.
Right.
Yeah. So that's Saturn, and that's already rising about 9:30 and spending much of the night. Saturn will reach opposition on, let's get this right here, August 2nd. So we're only a couple weeks away from opposition of Saturn. So on that night, Saturn will be Earth will be between Saturn and the Sun, so that'll minimize our distance from Saturn, and it'll be 74.3 light minutes away, or 337 billion kilometers. In fact, if I go up to August 2nd, you can do this with Stellarium, it'll tell you also how many AUs. So almost 9 AUs, astronomical units, away from Earth that night. And so the planet will look at its biggest in a telescope. It'll look also its brightest, because what happens is that when you view a planet with the sun behind your head, so backlit, coming from over your shoulder, you get an enhanced brightening effect. It's called the Selig or Seliga effect. I forget the exact spelling. But it's kind of like the the reflectors on the taillights of your car when you shine the headlights into them. The particles in the rings and the planet, the crystals it happens on the moon as well. So the crystals that the moon and rocks are made of give you an enhanced brightness right at full.
Is it that like if you're in a plane and you're looking at the shadow of the plane on the ground and it has like a ring of light around it? Is that it?
That's more of an atmospheric refraction diffraction process. This is more you're getting the reflected surface area coming back at you, but you're also getting a little bit of a mirroring effect of some of the small components that it's made of, or act like little mirrors and give you a little tiny extra boost on the brightness just at opposition. So yeah, it happens with the moon. It happens with any planet at opposition. So that'll be also the best time to see the moons. So on August 2nd will be your absolute best chance to see more of the moons if it's clear. And of course, a night or two ahead or behind of the 2nd doesn't make much difference. So don't worry if it's cloudy on the 2nd. All right, let's talk about Jupiter briefly here. And again, we'll go into this more next week. And I just want to mention that for in the short term, of course, in your telescope, you can see the great red spot every second or third night. And sometimes you can see shadow transits of the little moons casting their shadows. And I'll just get one here. So on this coming Saturday, starting a little before 11 p.m. in Eastern time, so you'll have to adjust for your time zone, Ganymede's shadow will cast itself on Jupiter, and that'll take a while to go across. Let me just advance the time. So by the time we get to about just before 1:18, about 1:15, you can actually use your telescope to see Ganymede kind of come up to and then kind of merge in with the disk. So you'll be able to maybe watch it transition from a separate dot and then kind of merge onto the planet's surface. So you'll get once Ganymede is on Jupiter, from our perspective, it becomes a little hard to see unless you've got good seeing and a good telescope. But the shadow will be quite easy to see. But wait, there's more. So a little while later, we'll get Ganymede's shadow leaving. And if you want to make a night of it, let me just bring this ahead.
Oh, is it a double?
So we're going to get, is it Europa Shadow? Yeah, Europa Shadow will appear. So around 3:39 a.m. or so, Europa Shadow will appear with the great red spot. So that's Sunday morning. And then you can do that trick and see Europa move onto the planet as well. So yeah, Saturn will reach opposition on August 20th. So all the same benefits that we talked about for Saturn would apply to Jupiter as well. Extra bright, extra big, and so on. If we go to the 20th of August, so the diameter of the planet will be 49 arc seconds across, so comparable to that big Venus in December that we talked about. All right. And then if you want to see other planets, let's go back to now. And I'll go back a couple hours here to around midnight. We've got Neptune following along. So Neptune is kind of around the western or eastern side of Aquarius. Neptune is a magnitude 7.8, so it's pretty dim. And then a little while later, we get Uranus. And Uranus is actually, can be seen with naked eyes if you've got good sky conditions and if you know where to look, but definitely in binoculars you can see it as well. Now, bear in mind that Uranus and Neptune are rising midnight or afterwards, and they're not climbing very high in the sky, which is what you need to be able to see them clearly. But everything rises about, I think it's a half an hour earlier every week. So a month from now, they'll be rising 2 hours earlier than this. So they'll be rising at 11 o'clock. So you'll have late evening chances to see them for late summer. All right. Mercury's not going to be really very well visible for the rest of this year, actually. It does have an appearance late October, I don't think, but it's not going to be, it'll be a pre-dawn one, and it's not going to climb very high. So we've kind of had our turn at Mercury for this year. So that's it for the planets. Anybody have any questions before we move on?
I think we are good so far, but if you have questions, throw them in the Q&A.
I didn't say this off the top, and I meant to, for those sort of keeping track of best times to get out under the stars. If you're wanting to look at the moon will be in the evening sky from now until about the 23rd of the month. So a few more nights, and then it's going to hit it's going to hit full. And once it's past full, it starts rising after midnight. So it becomes a late night phenomenon. And then it'll reappear as a young crescent moon on around August 10th. So that's August 10th to 21st, it'll be another moon period, which means that the best stargazing, moonless nights, will be July 30th to August 9th. And that's running up against the Perseid Meteors, which we'll get to in a sec. And then again, moonless period from August 29th to September 8th. So put your highlighter on your calendar, your astronomy calendar for those blocks. All right.
For anyone who's already got camping trips planned in that time period, well done.
Yes. All right. So let's go back to now. There we go. And I'll put on the meteor showers here. So we've actually got 2 meteor showers to look forward to in the next little while. We've got one underway right now. It's called the Southern Delta Akwarids meteor shower. So we need to find Aquarius. There's Aquarius. So there's the southern, let's see, I get this later in the night. There we go. There's the radiant for the Southern Delta Akwarids meteor shower. It's better for people in the southern hemisphere because it's such a southerly constellation for us. But we can see some. Its comet Machholz has dropped the particles that we're encountering for this meteor shower. It produces, I think, about 15 or 20 meteors per hour at the peak. The peak will be before dawn on the 29th. So that's Thursday, the 29th of July. And then it'll taper off beyond that until about August 23rd. Let's see, I think that one has, yeah, we've got a bright moon on that night. So it's not going to be a great shower to see at the peak. And then the other one is the Perseid meteor shower. So let me just back up a second and we'll talk about what causes meteor showers. And I really like this website. So this is called meteorshowers.org. And this is a 3D model. And what it does is it lets you see how the Earth's orbit and when it intersects with the other meteor shower. So we can change this to the Perseids. So there's the stream of particles dropped by the comet that produces, that's Comet Swift-Tuttle, has dropped the particles along its orbit and has produced, when Earth passes through that debris every year, then we get the Perseid meteor shower. So this is actually zoomed in. So here we go. So Earth is the blue. There's the blue dot going around. So if you look at, what you can do in here is you can play with this website. You can control the playback speed. You can even pause it and set the date. But you can basically see that Earth's orbit, the blue orbit, crosses the comet's orbit. And when the Earth ends up here, then we get the meteor shower produced. And for the Perseid meteor shower, it runs between now, about July 17th and August 26th. And the meteor shower will actually ramp up in quantity towards the peak. And that's because we're entering into the cloud of debris gradually. And then there'll be a night, August 12th, when we're passing through the densest part of the field of debris. And then we'll start moving out of it and seeing reduced meteors. So we'll get, each night we'll get more and more and more meteors until we reach the peak night. On the peak night of the Perseids, we can typically look for about a meteor per minute, one a minute. And they can be really bright. I've been out observing under the Perseids where I've been not looking for Perseids. I've been looking through my telescope and making notes about objects, and the whole picnic table will go daytime bright as the meteor goes across. And it's like, oh, what was that? I missed it.
So cool.
Now, of course, the number of meteors we see are controlled by the moonlight. Does the moon going to be bothering and washing and competing with the meteors? And luckily for us in 2021,
yay!
The moon will not bother us. So let's
finally we've got something going our way.
All right. So
we had past couple of years it hasn't been that good, right?
That's right. It's been a full moon. I think it was a full moon last year, the year before.
But we finally
let's look for Perseus. So there's the constellation Perseus, and there's the radiant for the Perseid meteor shower. Now, the radiant is simply the point in the celestial sphere where the meteors appear to be emanating from. And it has nothing to do with the stars. It has nothing to do with the constellation Perseus. All it is that on the night of the year when we're passing through the densest part of that cloud, the tangent to Earth's orbit around the sun points at that point in the sky. in the constellation of Perseus. And so we've just decided to name the meteor shower after that. So each of these meteor showers have their names according to the direction Earth is traveling when they peak. And basically, if you want to think of it this way, if the Earth is a car driving down the highway on a summer night with the bugs hitting the windshield, that's what the meteors are. They're bugs hitting the Earth's windshield. And after midnight, between midnight and dawn, is when your windshield is facing the majority of the particles. And so that's why they say it's best to look for meteors before dawn, because that's when the sky overhead, the windshield of the car is plowing straight into the cloud. The rest of the time, we're getting a bit reduced numbers of meteors because some of them are being hidden by the horizon and that kind of.
And that's because we're orbiting the sun counterclockwise and also spinning counterclockwise. And so as we're orbiting in this direction and the Earth is spinning counterclockwise, the sun's on that side, and it's right before the sun starts to come up as the Earth spins towards it.
Yeah.
That we're going straight into the meteors.
We're kind of turning into the stream and before dawn. Yeah. So, but that doesn't matter because as everybody knows, which you probably have seen, is that as soon as it gets dark in the evening after sunset, you can start looking for the Perseid meteors. They'll be showing up all night long, and they'll linger all the way until dawn. It's just that if you want to be a purist and get the most possible, after midnight is the best time, because a lot of them they'll be heading in every direction away from the radiant, and a number of them will actually be streaking across the sky but below the horizon. So that's why they say before dawn, when the radiant is highest, then you're going to get the benefit of all those trajectories above the horizon at the same time. Now, a couple more tips. So don't bother worrying about where the radiant is, because if you look there, the meteors are coming straight towards you, and they won't have any streaks. They won't have any tails because they're heading straight into the camera, right? So you might see a little flash or a little pop, but you won't really see a streak or a shooting star, so to speak. What are the shooting stars? What are those streaks? Well, when we encounter these particles, we have a delta V. So the Earth's motion compared to the motion of these particles in the comet's orbit can be many thousands of kilometers per second or kilometers per hour. I have to look up the number, but it's such a high rate of speed differential that when they encounter our atmosphere, they're actually produced streaking through the Earth's atmosphere at such a high rate of speed that they basically ionize the air and punch a tube of ionized gas in their wake. And that's what we see as the streak. Some of what we see is a little bit of this. What we see is the particle itself burning up, but most of the streak is due to the ionized air from Earth's atmosphere. And you can take spectra of those streaks, and you'll get, contributions of the atoms in Earth's atmosphere, but you'll also get additional contributions of the minerals that the particles are made of. The particles are typically the size of a grain of sand or something tiny like that. If they're bigger, you go back and watch our Insider's Guide on meteorites. If they're big enough to fall to the Earth, then we've got a whole session on that, how you can collect and find and buy and learn about meteorites.
It's on YouTube, as is this, if you're watching on Zoom.
Yeah. So the way you remember meteor versus meteorite is that most rocks, like granite, end in ITE, and that's why meteorite, ITE, because it's a rock that lands on Earth. So that's the difference. One little way of remembering. Yeah, so don't bother worrying about where the rating is. That's not what you want. What you want is as much open sky as you can get. All right. Again, I'll just go back to, I'll bring it up to the 12th of August here. Oops, I'll go back a little earlier. Here we go. So August 12th, we've got the crescent moon, and it's going to set and be gone by about 10:30, leaving the rest of the night nice and dark for meteors. So that's what we're happy about this year, is to have the moon gone out of the.
Yeah.
Yeah.
We have one question from BC, and I think, so the question was, do noctilucent clouds form from meteor dust? And if I recall correctly, in a presentation that I was a host of and was about 1/3 listening to, it's from greenhouse gases. Is that right?
I'm not an expert on noctilucent clouds, but they're definitely a meteorological effect in the Earth's atmosphere. So no, I wouldn't imagine they're related to meteor showers per se. In fact, they're produced by the geometry of the Earth-Sun system, and we've just finished prime noctilucent clouds period. We're done, I think, now. So yeah, it's not connected to meteors as far as I'm aware.
I think some people say it might be. I just don't know for sure if they actually know that or if they're just speculating. The idea is that clouds form around stuff that's like way, way, way up in the atmosphere. So I think some people have said meteors, and some people, I think it was someone from over the GA weekend, said that it might be to do with an increase in greenhouse gases as well. So this particle is super, super, super high up that water can grab onto and form clouds with.
Well,
maybe we'll have to do a special on them sometime.
Well, okay, so I see here on Wikipedia, the knower of all things, that it could be water vapor at high altitude. That's so they are clouds in that sense, but they're being illuminated in a special way. Or they could be ice crystals. Yeah, tiny ice crystals. That's more likely that they're ice crystals. So
yeah, it sounds like it's ice crystals forming on, or water vapor forming on methane, or methane, atmospheric methane, producing extra water vapor.
Well, you can get, yeah, you can get particles can be the seeds for participation of ice crystals. So yeah. So sorry,
we dove down a little rabbit hole there. Sorry about that.
Mark that down for a future session. I'll do some research and we can talk about atmospheric phenomenon in the future. So what you want to do for Perseid meteor watching is find a site that has as little artificial light as you can get. So the darkest you can get is great. You can get to a rural location, or even a half an hour away from most big cities will get you a sky that's nice and dark. As long as it's safe, obviously you want to make sure that you're safe. If you are heading out to the country, file a flight plan with a friend or family member to make sure they know where you went. And, be careful about having cell service and that kind of things in case of flat tires or whatever else could come up. But you want a site with, as much open sky as you can, because that's your basket that you're getting. The wider net that you cast has the most sky available to you. And just have a chaise or a blanket, lie down and just look up. If you're with friends, don't chat to them eye to eye or face to face. You all have to agree that you're going to chat while you're looking up, because if they're looking up and you're looking at them and they see the meteor and you don't, you'll be annoyed.
It's true. Yeah, you got to agree early on.
Keep your phone put away, or turn it way down in brightness, or get some red film and cover it up, or shut off notifications. Because you can have an astronomy app running on your phone like Sky Safari or Stellarium or something and have it set to night mode, so it's all red, and that's fine. But if somebody sends you a text, it'll come up as white. So it's a good idea to mute your notifications if you're using your phone out of your pocket. But yeah, and be patient. So take some snacks, take some drinks, and just take it all in and enjoy. And don't worry about binoculars or telescopes for meteors, because their field of view is too small to see meteors, and you're likely going to be, the meteor's going to miss your binoculars if you're using them. But have some time exploring the other objects in the sky, while you're there with your binoculars or your telescope. Just don't expect to see meteors through them.
I know Alundria. Alundria is the Sky News editor. And she's been getting more into astronomy lately. And she always gets really excited when she's got her telescope out and sees a meteor in her telescope's eyepiece, which you can see. It's just not always super likely, but yeah, she loves that.
Oh, I disagree. I think it's inevitable. I can't think of a time when I haven't been observing where I haven't seen, well,
Really?
maybe not a meteor, but definitely a satellite go through my eyepiece.
That's fair. That's fair. Yeah, something moving.
Yeah. So yeah, now it's a true Perseid, as I said, if the direction seems to be traveling away from the constellation Perseus. You won't only see Perseids though. You can see what we call sporadic meteors, which can be just particles that are drifting around in the solar system and get caught by the Earth. They may not be part of that shower. And so if you see a meteor during the Perseids, but the direction seems wrong, it's just simply part of a different shower or a rogue particle that's wasn't part of the comet's debris. So that's perfectly legal, and won't be excited if that happens. You might see some fireballs, some bigger particles that shoot across the sky and kind of spit sparks, seem to disintegrate as they go. The other thing to be mindful or watch out for are smoke trails. So sometimes the meteor goes past and the burning up component of the process leaves a little cloud of smoke, like a contrail, and that can last for a few minutes, and it'll sort of dissipate, maybe change shape as the Earth's atmosphere, the winds kind of dissipate it. So that's a cool thing to look out for too. All right. Any other questions on meteors?
So far, I think we're good. Yeah, we're good.
All right, so let's talk about, I'll just go back to tonight. Let's just give people some suggestions on what to do out under the stars. Since we're talking about summer stargazing and the moon's always around, I'm not going to worry too much about the moon right now, but you know, if people have questions about the moon, we can come back to that after. But let's just focus on what else is around. So as I said, the moonless period, the next moonless period is going to come around July 30th. So let's just set the stellarium to July 30th. Get the moon out of the sky around 11 o'clock. And the first thing that I like to suggest for beginners, especially, is to look at the colors of the bright stars. So we've got the bright star Arcturus, which is up in the southwestern sky, about halfway up. And you'll notice if you pay attention that it's actually has a bit of an orange tint to it. So it's considered a K-class star. So it's not quite a red giant, but it's getting there. So it's kind of a warmish color, reddish, orangish color. Down over the southern horizon, we've got Antares, right? Antares is the heart of the Scorpion. Antares is an M-class star, so it's a cool, low temperature red giant star. So you'll see you definitely notice has a reddish color. And then compare those ones with the summer triangle. So the summer triangle stars, Vega, Deneb, and Altair. I'll just put the triangle up on here so people can see the triangle shape. And Vega around 11 o'clock will be up near the zenith. So the Z is the zenith straight up over your heads. So Vega will be really easy to spot. It'll be the brightest star in the nighttime sky. And it'll be Vega and Deneb and Altair are all kind of white colored stars. They're A, they're at the other end of the spectral classification system. So they'll you know, burn their fuel rapidly and live fast, die young, shine brightly for a little while. So do compare the colors of the stars. That's a fun thing to do, and to teach your friends or parents or whoever you have with you, relatives. Look out for the International Space Station, and we can also see the Chinese space station from time to time. If Jenna puts in the heavensabove.com link, we can look at that for just a second. Won't spend a lot of time here, but basically you go to heavens-above.com, you click up in the upper right corner, or you can also do it with this link here, and you basically want to put in where you're viewing the sky from. So it could be from home, or it could be from your cottage, depending on where you plan to be. Once you've set that, and you don't need to be super precise, you can just search for the nearest town and you should be pretty good. Timing is important, but it's not exactly important that you have your exact latitude, longitude. And then once you've got that set, come back here to the list where it says satellites, and you can do all the different passes for the different types. And you can even get, you know, what's going to be up in my sky tonight, all the different satellites. So if you do this one, then it'll give you the date. You can change the day and the month, and you can tell whether it's morning or evening. And then the way you interpret this graph is you've got the name of the object, the brightness, and the lower the number and the more negative the number, the brighter it is. And each integer difference represents a brightness difference of 2.5. So Vega, the star Vega, is magnitude 0. And the ISS here of minus 1.2 will be more than 2.5 times brighter than Vega during this pass. The ones that are positive, so let's say a 3, will be 2.5 times fainter, times 2.5 times fainter, times 2.5 times fainter. So for each integer from Vega, 0, 1, 2, 3, jumps down by 2.5 for each integer number. So whatever 2.5 times 2.5 times 2.5 is 1 over that. it's like 1/10 or something like that.
Drops off fast.
Yeah. So once you've got the object you want to look at, find one that's going to be bright. Then this gives you the time it will appear, the time it will be highest in the sky, and the time it will disappear. And the tip here is to look for the altitude in the sky when it's highest. So if it only gets as high as 22 degrees, that's just 2 fist diameters above the horizon. That's barely above the horizon. In fact, most trees and buildings will block that. But if you see something that's got a 45 or a 60 or a 70, something like that, then chances are it's going to be nice and high and easy to see. So I'm going to go back and I'm going to go to the list of just for the space station, just the ISS. And here's a week's, maybe, yeah, almost 10 days worth of ISS passes. So you want to look for something that's nice and negative. So here's a minus 3.5 on the 25th. So that's Sunday night. And it's going to appear at 11:21. Reach its highest point at 11:24 and something, and then disappear at 11:24 and something. And so if you click the date, you get a sky map. So it'll rise from the horizon, and after a few minutes, it'll disappear into Earth's shadow, and then we'll lose sight of it. But it'll be really bright. It'll pass right through the Big Dipper, and then it'll pass the Little Dipper, and then it'll disappear in Earth's shadow. So that's Sunday night. And let's see what other good ones we got. That was that one. Here's an 83 degrees one on the 28th. So on the 28th, that's a week Wednesday. And that's going to be another really, really bright pass. So that's how you understand these graphs and these charts. And you can do that, and you can go back. You can look for the Chinese space station. That's the, where is it here? Tiangong. No passes for the Toronto area, but you could check for other parts of the country and you might luck out. Here's one on August 8th. That's not too bright, but you can see it. So that's something you can do without binoculars or telescopes, just your unaided eyes.
And just a heads up as well, I don't have Astrospheric on my laptop, but it also has ISS passes in it, and they're visualized really nicely, and they're really easy to find. And there's one from tonight, similar thing. I just love Astrospheric. I'll stop now.
Yeah, it's a great app. Okay, what else can you look for? You can look for asterisms, which are informal star patterns. So as I said, we've got the summer triangle, Vega, Deneb, and Altair. We've got the teapot down here in Sagittarius. Man, if we were naming these constellations nowadays, I don't think we would have called this the Archer.
No,
we would have called it the teapot.
It's 100% the teapot.
Yeah. But they saw a bow and arrow in here. I don't know how they did that, but and of course, Scorpius is very, very memorable and very distinctive. And if you're a fan of the movie Moana, of course, Scorpius is Maui's fishhook. That's what the Maori of New Zealand call this pattern of stars, Maui's fishhook. And I like Ophiuchus, which is not a very famous constellation, even though it is technically part of the zodiac. Because to me, Ophiuchus looks like a Dalek from Doctor Who. So you've got the skirt at the bottom, the pointy lid, and then there's even a kind of a pipe that sticks out of stars on one side, like an what do you call it, a disintegrator beam thing. So I like Ophiuchus. Over in the north, if you want to impress your friends, point out to them Mizar and see if they can see a little Alcor sitting up beside it. And that's a kind of a classical eye test to see if everybody could see that. And then, if you do have a telescope handy and you want to put your telescope on Mizar, it splits into a beautiful little double star. And most eyepieces will show this combo of the split Mizar, Alcor above it, or it'll flip upside down for your telescope, and then another little star off to the side, making a little set. So that's the Dipper's handle.
There's real quick, just backtracking to the ISS for a second. VJ from YouTube also suggested the Spot Station email notifications. You can have them email you when there's going to be a good ISS pass.
Yeah, you can sign up. You can sign up for a number of different apps. We'll give you a warning when it's coming. What's cool about the space station is that there's no prep, there's no telescope aligning, you're setting up. You can be watching a movie and your phone will buzz and you just pause your movie and go out for 2-3 minutes, watch the space station, wave at the astronauts, and then come back and continue.
It's also a really nice beginner astrophotography target. Like if you're just starting, you can set the exposure time to like a minute or something like that, or 30 seconds even, and you get this really nice bright streak across the sky, and it just makes it kind of fun and interesting.
Yeah. And if you catch the space station when it's rising in the east or setting towards the west, when its motion is rather simple across the sky, you can sometimes catch it in your telescope. If you have a manual telescope, you can.
Oh, that's cool. Like
so
if it's just in one axis.
Yeah, don't put too strong an eyepiece in, one that gives you a degree field of view or something like that, and you can watch. You can either use the charts to know what star it's going to go past and then be ready and watching and see it go by. Or if you're really coordinated, you can actually take your telescope and follow it.
Cool.
And get glimpses of it.
Wow.
I've done that. It's fun. Okay, a little more on the naked eye side of things. So it's fun to appreciate the Milky Way and to start recognizing its structure. And that's really evident up in Cygnus. So Cygnus, the Great Swan or the Northern Cross, straddles the Milky Way. The tail to the nose is Albireo, the double star. We'll come back to that in a sec. Is parallel to the Milky Way, and in this part of the Milky Way, you really get to see the dark dust lanes dividing the Milky Way into zones and patches. And that's very easy on a dark night to see that. So just realize that you're seeing the structure of your home galaxy when you're seeing that. You're seeing the dark, opaque dust obscuring the stars that are beyond it.
That always blew my mind, is that the dark spots were not a lack of stars. They were just that there was something in the way of our view. Yeah.
So in my other app that I use for presenting, that's the Starry Night app. I have a version where the whole sky is shown in infrared, and that removes the dust, and so you can see the galaxy continuously through the sky in infrared. Cool. It's kind of fun because infrared light passes through the dust.
Right.
All right, so what else? A couple of variable stars I thought was fun. So if we look at the constellation of Lyra, that's where our friend Vega is. So again, Vega's the bright star, almost straight up in late evening. And then once you've got Vega and you're comfortable with that, you can look to the left about 1 finger width. So if you put your finger up and put Vega on one side, on the right of it, on the other side of it, the left of it, you'll see a little star. There's actually, these form a little triangle. Each edge of the triangle is about a finger's width in the sky. And this star is Epsilon Lyrae, or the double-double nicknamed the double double. So to your unaided eyes, you might see one star, you might see two stars if your eyes are really good, like you've got, if you're young and you've got sharp eagle eyes, you might see that it's two. Binoculars, no question. As soon as you put binoculars on it, it'll split into two. And then if you throw your telescope on it, each splits into two. So the one star becomes two, and each of the two becomes two more. So you get a double star. And that's what the double double is. And we nicknamed Lyra, which is the harp in Greek mythology, but we call it the Tim Horton constellation because it's got the double double already, and it's also got the donut. And the donut is the ring nebula. And if you point your telescope between the bottom two stars of the parallelogram of Lyra, right in the middle, then you can find the ring nebula. It won't be in color for a backyard telescope. It'll be gray, but it's actually, of course, it's not a ring. It's actually a sphere. It's basically more like a soap bubble of glowing gas because of the star massed like our sun, reached the end of its fuel, collapsed under its own gravity, then blew off its outer shell, leaving its core exposed as a white dwarf. That's a little star in the middle. And the radiation from the white dwarf is causing the gas sphere to glow with different colors. And that gives you the ring nebula. So there's your donut, coffee and donut. But back to the variable stars. So get yourself familiar with the box, so Vega plus the 4 stars in the parallelogram. The one at the very bottom is named Sulafat. The other one is called Sheliac. And then the one to the upper left here is Delta. And then the one at the upper right is Nazar Al-Waki, or what is that? Eta, I think. I can't remember, but the one that we want to look at is Sheliac. So Sheliac is a variable star. It varies in brightness. It's an eclipsing binary system where a main star has a small companion, and when the companion disappears behind the main star, the total output of the two stars is reduced down to one star, and the pair of them dim. And then when it's revealed again, they brighten up. They'll also dim a little bit when it passes in front of, one star passes in front of the other star. And then, so you get this cycle of brightening and dimming in the system that takes about 13 days for that cycle to repeat. And so the amount that it varies in brightness is between magnitude 3, about 3.3 to 4.4, which is one integer jump, which is a factor of 2.5 times in brightness over that cycle. And so when Sheliac is at its brightest, it's bright as Sulafat. And when it's at its dimmest, it's as bright as Delta.
Huh.
So it's super easy to tell just by your eye which one where it's at. Is it closer to this one or closer to that?
Cool.
So you're seeing that in action. And don't forget to come back and check after a number of nights and see if you can see the difference. Another variable star you can look at is Almazan 2, or Eta Aquili. Now remember, here's the summer triangle, Vega, Deneb, Altair. Altair is in Aquila. So the lower wing star, kind of the elbow, the southern elbow of the eagle, it's a Cepheid variable star. That type of variable star pulsates and varies in brightness on a cycle. And that varies by about a magnitude value from 3.5 to 4.5 over a week, seven and a bit days. And so when it's at its brightest, it shines the same as Lambda. I think that's this star. So if you can see the tail, so if it's the same as the tail, it's near its brightness. And when it's near its minimum, it's near Iota. I think this is Iota, little star in the bottom corner. So you get to compare these three and see where in the cycle you're at. So that's stellar astrophysics right to your naked eyes or binoculars. Yeah.
And that's usually how people go about, like when Betelgeuse was in its little dimming period, that was how people were telling the brightness, right? They'd like compare it to how bright other stars were of a known brightness.
Yeah, I mean, there's an organization called the American Association of Variable Star Observers, AAVSO,
VSO.
and they love it if you do analysis, do observations, and estimate star brightnesses and submit your observations. And for these stars and many other stars, they actually have campaigns where they say, we need more people to look at a certain star. Can everybody take a turn and send us what they see? And they teach you how to do that. They give you charts that have comparable stars, that have known brightness that you can compare them to. And you can do citizen science or community science or whatever we're calling it these days. But yeah, it's a fun thing to do. All the different astronomer friends that we have all have different loves, and we have people that love double stars like Blake Nancaro, and then I've got I think it's Andy Beaton who really
he loves variable stars.
Variable stars, yeah.
I'm an exoplanet person.
And then there's Jana the exoplanet.
Yeah.
Right. Yeah. Speaking of exoplanets, this is the part of the sky that the Kepler spacecraft used for its search for exoplanets. And this pattern of dots that you're seeing here is the patch of sky that the spacecraft stared at for several years and measured the way that the stars in that patch varied in brightness due to these eclipsing binary systems and the other phenomena. And so, yeah, it's in that spot between Vega and Deneb. So when you're looking at that patch of sky, you can think to yourself, that's where humans know of most of the exoplanets in human history so far.
It is really cool just to look at that and think like that is probably the same in at least the plane of the galaxy.
Yeah, you can Google a little bit about Kepler and you can figure out just what a paltry part of our galaxy that represents and how much more there must be out there. Yeah. The TESS mission is busily doing an all sky survey right now. So they're finding many, many, many more. Yeah, so speaking of the Summer Triangle area and getting into binoculars, do use your binoculars to explore the Milky Way. You know, start at the teapot and look for these little brighter patches, little knots of brightness. Those are nebulas and star clusters in the plane of our galaxy. If you're curious to see the center of our galaxy, you can go into Stellarium here and go into markings, and you can hit galactic, let's see, galactic poles. I want galactic center and anti-center. So that little symbol GC represents the position of the supermassive black hole that's in the core of our Milky Way galaxy. And it's sitting here just beyond the spout of the teapot in the sky. So not much to see, you know, dramatically with your binoculars or telescopes, but astrophysicists are certainly interested in that patch of sky because they can peer into it and see the inner workings of the core of our galaxy. But yeah, do start above the teapot and start exploring. You can see all of these. I'll bring up the Messier objects. So all of these NGC and Messier objects, these are all clusters and nebulas above that patch of sky. If you've got a telescope, you can zoom in on some of them and you may or may not see the stars within the gas clouds and some wispiness around them. If you have narrowband filter sphere telescope, you want to use your Oxygen 3 or your UHC, your ultra high contrast filters, will darken the sky and enhance the glow of the gas around them. We've got this one. Let me just bring up the names here. DSO. I'll just take off the designations. Yeah. So here we've got the Trifid Nebula. We've got the Sagittarius star cloud. We've got the Omega Nebula. This is one of my favorites because it looks like there's a bright patch that looks like a swan floating serenely on a pond. And because your telescope will flip things around, it's right way up in your telescope. So it's kind of cool. And then above that, we've got the Eagle Nebula. The Eagle Nebula is the one that had the pillars of creation, that famous Hubble Space Telescope. That's the fingers of dark dust that are sticking into the glowing gas. So those are things you can explore with your binoculars or a small telescope. You can look for the wild duck cluster up here in, remember our friend Aquila the eagle, and we were looking at Lambda, the tail. So the wild duck cluster is just off the end of the tail. And in binoculars or a telescope, you'll see this big, bright clump of stars. That's an open cluster.
Beautiful.
Yeah. Let's see. Over in Ophiuchus, if you find the star in the middle of the base and the star at the peak, then that line will guide you to a number of globular clusters. So find that line and go a little below, and you can find Messier 107 globular cluster. I'll just turn off so that'll be a fuzzy patch. You might be able to see that with your binoculars from a cottage or from a dark rural location, but definitely in a telescope. Globular clusters are really good for suburban stargazing. So you can see them even from the suburbs. You don't need to be in a dark sky site to see some of these. Messier 10. This is a really bright one, 6.4 magnitude. And then just a bit to the west of that, you've got
that's
Messier
cute.
12. Yeah.
I'm a big fan of the lay people's names that they give these, like the non-scientific names, like the gumball globular cluster. That's adorable. The flying unicorn cluster, like, sure, why not?
So in the latest Sky News, I've got the article
Hey.
talking about the Tweedledum and Tweedledee. So
those are good ones.
So Tweedledum is this open cluster. It's right near the Daleks disintegrator. Again, here's Aquila, and then Graph's cluster is its partner, but astronomer Stephen O'Meara decided that it should be Tweedledee. So it's Tweedledum and Tweedledee.
It's just so
together.
cute.
And they're great for binoculars. Let me just bring up the field of view of binoculars here. I'll make this about 6. So they'll fit nicely in binoculars.
Ooh, very nice. Also, is this the issue of Sky News that you were talking about?
Yes.
Yay! Here's
the current newsstand edition. Yeah. Speaking of the current newsstand edition, 2 more fantastic objects to see with binoculars from a dark sky site or your telescope is in Cygnus. And if you remember our friend Deneb, and aim your binoculars just a little bit below Deneb, look for a brightening patch. That's the North American Nebula, NGC 7000. And it's beside it is something called the Pelican Nebula. I don't know if you can see there's a pelican's back of his head, then his beak stretches down, his chin's up in here. He's kind of turned sideways. Let me just turn it sideways for everybody to see it. There's the pelican. And this glowing gas is all one complex. It's just that it has dark dust intersecting it or bisecting it and producing a shape. And so here's North America. There's Mexico. Here's Vancouver. Here's Canada. Here's the Maritimes. Down to Florida. There's a star in Florida that would be Disney World or Universal Studios.
So funny.
And then up near the top, there's kind of a dark ring that's called the bird's nest. And that's just dark dust. That's with stars in the middle. So that's nicknamed the bird's nest. So pick up your Sky News and take a look. I did a full tour of the neat features of the North American Nebula. But this is binoculars. You can see this in binoculars. If you have a telescope, use that nebula filter, UHC or O3 filter to brighten it up. It's really effective.
So on page 24 and 25 of the current issue, and on the next page, there's a big sky star finder chart thing with all of the highlights of the season next to it.
Now, while you're there, so while you're in Cygnus, go over to the center of the constellation. That's this bright star in the heart of the swan, and then drop down the southerly wing. So it's got 2 stars, 3 stars that make the wing. After you finish the first one, before you get to the second one, you'll notice a naked eye star off to the right. right here. The star is named as 52 Cygni. And if you put your binoculars on that star or your telescope and zoom in on a dark moonless night from away from city light pollution, you might see this. And this is the Veil Nebula, or the Cygnus Loop. And what it is, it's the raggedy remains of a supernova explosion of a star that blew up and blasted its contents into space. And it's this ever expanding and dissipating cloud of gas. And the star 52 Cygni is in the foreground, but it just acts as a guide for us to help find it. So this section of the nebula, I think it's sometimes called the witch's broom. You can sort of see why. And it runs right through the star. And so if you center your telescope on the star, just notice the streak of light that passes across it, and that's the nebula. Once you've got that, you can sort of start tracing it around, and you can even swim across the way and find the other side. And again, the diameter of this object is about, let me just see if I can remember here, about 5 times as wide as the full moon. So 2.5 degrees side to side.
Pretty big.
So you'll find, yeah, there's 2 main sections that are brighter, and there's one in the middle at the north that's bright. I walked Jenna through on Discord to find this from her cottage.
Last year we did an observing party, voice only, on our Discord channel, and for the Perseid Meteor Shower, and Chris showed me how to find that just using words, and it was so cool.
Yeah, yeah. So it's not as bright as the North American Nebula, but it's fun. It's really fun to see if your skies are dark. Yeah, so before we leave, while we're here, and again, another pitch for Sky News, is if you aim your binoculars midway between Vega and Altair, you're going to pick up the coat hanger.
Yeah.
So there's the coat hanger. Let me just connect the dots for you. So it's upside down for Canadians, but it'd be right way up for Southern Hemisphere people. But it's an old-fashioned coat hanger with a line and a hook. And you'll notice I mentioned in Sky News that most of the stars are the white kind, white class, but there are a couple of reddish stars in the mix as well. And there's also an open cluster, a faint open cluster off one end of the row. So if you've got a dark sky, you can look for that open cluster as well.
Linda Playa in the chat also mentioned the coat hanger, and Linda was the first person to show me the coat hanger. So I have a lot of my astronomy mentors around right now.
Very cool. We're all here to help each other, right? So when you've got your summer triangle figured out, your Vega, Deneb, and Altair, and by the way, it's visible until November. So it appears in summer, but it hangs around a long time because as the sunsets arrive earlier in the fall, it lets us continue to see them. Once you've got the triangle, zoom in on the middle of the triangle and look for the little star in the middle. It's not very bright, but it's visible to unaided eyes. And that's Albireo. Albireo is the nose of the swan. And in a telescope, Albireo splits into this gorgeous double star, 2 different colors, 2 different brightnesses. The Gaia space mission has been measuring the distances and locations of the stars in our galaxy. And I think they've reported that this is a coincidence line of sight double, not a gravitationally bound double, the way many are. So it just happens that one is closer, one is farther, but they're in the same direction. So that's a fantastic thing to show people in a backyard telescope. It's easy to see it. The splits really easily, and you can see the colors and get people to think of what they see in the star colors. Don't announce it yet, and then take a poll, see what people thought.
Yeah.
So that's Albireo. Let's see. Any other things I want to talk about? I think the last thing I'll talk about Hercules, and I'll talk about a comet. So find, if you found the triangle, you can go to the right of the triangle or west towards the bright star Arcturus. So about halfway between Altair and Arcturus, or even between Vega and Arcturus, is where Hercules is. And Hercules is not too bright, but you want to look for this keystone shape pattern of stars. And if you can find that, One side is on the east, one side's on the west. It's narrow at the bottom and wider at the top. Find the western or right-hand side and aim your binoculars or telescope about a third of the way from the top. And you'll find this. That's another one of the globular clusters. That's Messier 13. It's one of the best and brightest globular clusters visible from the northern hemisphere. So it's well worth checking out, looking for. Even better than the ones in Ophiuchus. So definitely go after this one. M13. So you want to check out that. And then there's another globular cluster called M92 that's not as easy. It's smaller, but it's above Hercules's legs. So you can find that one as well. So yeah, use the charts in Sky News or your app to help you find some of these objects. Yeah, the last thing I wanted to talk about was a comet that's may or may not be too readily visible by folks. It's kind of an early evening comet, and I think I can find it here. Let's see. It still remembers ephemeris. Yeah. So July, let's go to July. Let's go now. July 20th. And we'll go to July 30th. Calculate. So this is a comet named C2020 T2 Palomar. I'll just find it here so you can put it in here. C-2020 T2 Palomar. And I'll go back to tonight. So as of tonight, it's traveling between the two legs of Virgo. And I think Jenna likes to call this I've fallen and I can't get up.
Oh yeah, yeah, help me, I've fallen and I can't get up. And then I think Pegasus is my horse has fallen too or something like that, yeah.
So I like that. I think that's a great name. So the fallen person's legs, basically from the knee off the other way. So every one of these little symbols represents one night of travel. So this is tonight, and every night it'll hop a little bit towards the southeast. So I think right now it's magnitude about 10. What I can do is I can bring up a chart here. Let me just bring that up for you. So I use this. There are different sites for comets, but I use this one called Aerith, AERITH.net. And there's Palomar. And it gives you a chart where it's going, and it gives you reported brightnesses by observers. And you can see the red line is the predicted brightness as it reaches perihelion with the sun and then starts leaving. But right now it's around its maximum of around magnitude 10. So that's within reach of a backyard telescope. Not super easy to find, but if you have a go-to telescope, the comet itself may not be in your database. What you can do, and I like to cheat using this, is I just like to see if there's any NGC objects that are nearby, because those will be in your database. So if you go to NGC 5501, you can use that to get you in the neighborhood, or you can look up some of these dimmer stars and find out where it's going.
Sneaky.
Yeah. So here on the 27th, it's going to be passing this star, which is not too dim, only magnitude 6.8. And then around the 30th, it's going to be passing NGC 5604. So you could type that into your go-to telescope at the end of the month and find that.
If you all remember the very disappointing year that 2020 was, for comet reasons specifically, a lot of the comets on that chart that Chris was showing earlier with like the expected brightness versus observations from people, all of the comets that we kept seeing were like the expected brightness was like super great. It was going to be fantastic. And then the observed brightness was like a huge disappointment, except for Comet Neowise. We did get Comet Neowise.
Yeah. Comet Neowise was definitely a highlight of the pandemic for a lot of us astronomers. It was a really nice gift, but we never know. We never know what we're going to get. So we keep an eye and that's it. So I think I'll stop there. That's lots of ideas.
Yeah. We do have a question from VJ on YouTube, which was, is there any way to set stellarium so that it shows you what you actually see and not what like astrophotography shows us?
Yeah, so let me show you how to do that. So I'm going to turn off the So there are a couple of things you can do in Stellarium that I don't do. And if you go to the settings, so this is tonight at 10 o'clock. You can see we've got the moon in the sky. And if you go to viewing options F4, go to the sky. And you can do things, you can do dynamic eye adaptation. This might be switched on by default. And if you do this, it makes the moon, when the moon is bright, it makes everything dim around it. So it makes it more realistic. So I don't know whether this is going to make, it doesn't make that much difference right now. When the moon is full, it makes a big difference. The other thing you can do is, go back. If you want to make the sky match what you see, is you go up to where it says stars and you just tweak the absolute and relative scale. So the absolute scale, let's see if I can make, yeah. As I bring this down, I get fewer stars in the sky. This kind of increases the effect of that. The relative scale changes the difference between the bright star dots and the dim star dots. So if you want a big dramatic difference, you can change that to make them, you know, big globs for bright stars. The other thing you can do is you can go over to your light pollution and you can turn off the, you know, atmosphere altogether, but you can actually play with the amount of light pollution that it factors in for you. And you can even get it, it'll consult a database and set that for you. I don't use it. But.
What about for deep sky objects? Because this shows us the Vega Nebula in like beautiful red and blue, when normally we would just see like a kind of fuzzy whitish spot.
Yeah, so there's no way to switch it to black and white, although you could probably go to night mode. And that would be a bit more, realistic to what you'd see. The other thing you can do is, if you've got it set, is you can switch from the photos that are built in, and you can go to DSS. And DSS is the Digital Sky Survey image.
That's better.
And
that's closer, yeah. I should say.
Yeah, so you could use that. The thing is that when you're using the DSS option, it's going off to the web to tile the view. So if you're using a wide view of the sky, it'll take a while to load it up.
Fair,
so it's better if you've already zoomed in on the object before you switch it on.
Okay. And with that, I think we're actually technically out of time. We've made it.
Well, hopefully we've given everybody, inspired everybody to get out and take a look. And
I have some general wrap-up thoughts. First of all, Chris, thank you so much for sharing so many awesome summer targets with us. We just, as Brian said, we just need the sky to clear up a little bit here because it's just a little too, the weather's not super great. Our next episode is going to be in August, and it'll be on August 17th. And we'll be talking about gas giants. We're doing only one session in July and August, just to keep the schedule light in the summer and to make sure that we and you all get to go out observing whenever we have the chance and the weather is clear. Other stuff that you can take a look for coming up, Sky News, if you do have this issue of Sky News, the editor and a friend of mine who is a satellite engineer, and I did an article on space games. And for the next 2 Wednesdays, we've already done 2 sessions. For the next 2 Wednesdays, we're reviewing those games and also playing them on the RASC YouTube channel and also in a webinar. So there's more information in the link in the chat if you would like to join for that. And finally, in August, I'll also be running an exoplanet processing course. And we'll be using data from the robotic telescope with RASC. It is paid, it is not free, because I had to gain all this knowledge. And I also have to make an argument for why I should still be hired. And so it's $50 a person for 5 sessions throughout August and then the first week of September. And we'll be processing data and looking for exoplanet transits as they pass in front of their stars.
Fantastic.
And I think that's it. Chris, did you have anything you wanted to shout out?
No, just everybody, please get outside and blow the smoke away the best they can, or hopefully the folks out west can help get the fires put out and get under control safely, we hope. And let's hope we can get rid of COVID and we can all get back together to star parties and start sharing views through the telescopes, and that would be great too. But good luck with the Perseids. We won't be seeing you again until after the Perseid shower peaks. So good luck, everybody.
Share your photos with us if you take any, and let us know how your experience was. Maybe we'll do a little brief overview of our Perseids experiences before our next episode.
Yeah, and next month we'll talk about planets and how you can see little eclipses and more shadow transits and all that kind of neat things. So we'll see you then.
Thanks everybody for joining.
Keep looking up.
Clear skies.